so this video is going to be section 4.8. So now we've already kind of talked about this. We did some hand waving of it before we started test 3. It's antiderivatives. You might also know them as integrals. We're going to talk about the two pieces. Alright, so how to find an antiderivative? First of all, we have to define it. A function capital F is an antiderivative of little f on an integral I if the derivative of the big function, the derivative of the antiderivative, equals little f. Now, this will all come together as we work through it. The notation will sometimes be capital F, sometimes be little f. Traditionally, capital F is used if we talk about antiderivatives, which is the opposite of a derivative. But you're going to see as we go through the section that that notation isn't used very often in the big picture of math. Alright, so theorem. If capital F is an antiderivative, opposite of a derivative, of little f, then the most general antiderivative of little f is this function here. Why? Well, if we were to take the derivative of this, dx, then the derivative of capital F is little f. By definition, capital F is the antiderivative, so if we take the derivative of that, we get little f. The derivative of c is a constant. What's the derivative of a constant? 0. So we end up with just little f. So capital F is the antiderivative. Technically, there is more than one. You can add any constant you want to your antiderivative, and that is defined to be a family of antiderivatives. Technically, because you can add any constant you want, there are infinitely many antiderivatives to any one particular function. So you're going to see this whole add plus c thing throughout this section, because when we write a general antiderivative, we always write plus c to denote that this is a family of possibilities when it comes to antiderivatives. Now, at the bottom here it says, we can find a particular antiderivative from this family when we're provided what's called an initial condition, or any condition. It doesn't have to be the initial. I'm going to show you an example of that first, and then we're going to do lots of practice. So here's our problem. Find an antiderivative of this function, little f. So think of this as being, the derivative is done. Now how do I get back to the original function, the antiderivative? How do I undo the derivative that's been done? And it satisfies this condition. So we're looking for capital F, and this f of 1 equals negative 1, that's going to help us find our c. Now this is, we're going to call it an initial condition. It's technically not an initial condition, because it's not f of 0. It's the same concept. They give you one particular value at one particular point of x, and with that you can find your c. So we use that at the end to find our plus c value, a particular solution. Alright, so let's go back to f. If f of x is 4 to the x cubed, I want you to think about what would you need to start with. What would the antiderivative have to be? So that if you took the derivative, you'd end up with 4x cubed. What function, when you take the derivative, give you 4x cubed? Well, it looks like the power rule. Remember, we bring the power down and we do one power less. So what would our power have been if we had not taken the derivative? Power would be one more. So let's stop right there and ask, okay, if I take the derivative of x to the 4th, do I get little f? 4 comes down and x to the 3. Yes, we do. So that is one possible antiderivative. However, we want the family. So we're going to put plus c. Now we have all possible antiderivatives. No matter what number you put for c there, when we take the derivative, it disappears. So we would get little f. Hopefully this is making sense. If not, shoot me an email and I'll try all this all over again. I got lots of examples. Now, using our initial condition, we can actually solve for the c value. So it says that f of 1, plug in 1 for the x, so 1 to the 4th plus c. It says f of 1 has to equal negative 1. Solve for c. 1 to the 4th is 1, so 1 plus c is negative 1. We bring that 1 around to get c by itself, we find that c is negative 2. So if c is negative 2, that means the particular antiderivative to this problem is our x to the 4th plus the c that we just found, which is get the value that it said it should be. f of 1 would give you negative 1. Now, there is another notation for this. This is actually, I'm reordering your notes here a little bit. This is the last problem in your notes. Indefinite integrals. Indefinite integrals are basically antiderivative. Well, they are antiderivative. It's just a different notation for writing it. So, the definition is, if I put this little curly Q symbol here, this is not an S. Please do not write S, F of X. That is not what this is. This symbol here is a long line with a little curl at the top, a little curl at the bottom. This says take the antiderivative of the function inside. And the dx is telling you who to take the antiderivative with respect to. In our course, the variable inside and the d whatever variable, all the variables will match for our course. If you move into calculus 3, though, it is very possible to have more than one dx. You got dx, dy, dz, d alpha, d theta, d alpha. There's a whole bunch of things that can happen in that course. So this notation is going to become more interesting in Cal 3. But for now, it's just going to basically say this little integral dx together, these two pieces say find the antiderivative. Now, what do we do? Let's see, do I want to do example first? No, they're doing it first. Alright, so let's work up to that more interesting example. I just want to show you the notation. So find the antiderivative of the following function. So it's your choice. You can call it capital F of x, meaning I'm finding the antiderivative, or you can write out what you're going to do. So capital F of x is technically the antiderivative or the integral of x to the 7 dx. This means keep the antiderivative with respect to x. Alright, well, I see a power rule here, but this isn't like the one we did a minute ago. There's not a number in front. Alright, well, let's start with power rule. So power rule says, if I'm taking the derivative, I bring the power down and I subtract 1. So I do the opposite. Let's add 1 to the power. That's the main part. The power is the main part. Now, let's check. Let's test this. I am guessing here, basically, and guessing that this is the antiderivative. How do I check my work? The derivative. Well, what's the derivative? The derivative of x to the 8. I'll just put right out the notation. So dx, the derivative of x to the 8, is power down, x to 1 power less. Oh, we're close. We're so close. But I don't have an 8 in my number, in my little f function. So how do I fix that? What you're going to do is you're going to divide your antiderivative by 8 to fix it. So we're going to divide by 8. So now let's adjust our derivative. So instead of x to the 8, we're taking the derivative of x to the 8 over 8. Well, that over 8 part just stays underneath. It's a constant multiple, which means we can simplify this and we end up with little f. Now, if you were here, I would make you all figure this out, but since you're not, I'm going to have to give you the answer. And the answer to this, oh, don't forget your plus c. The answer here is that there is a shortcut for doing power rule backwards. If we have power rule backwards, so this is the antiderivative. If you have the antiderivative of x to a power, the power rule backwards is as follows. You add 1 to your power, and you divide by your new power. Don't forget your plus c at the end. So this is the power rule backwards. So this was our answer. Alright, let's try another one. So little f of x here. Again, just like with derivatives, we don't like roots when it comes to antiderivative. So let's get rid of the root. So this is really 1 over x to the 1/3. But I really don't like fractions. Can we get rid of the fraction? We bring x upstairs. This is x to the negative 1/3. So how do we find the antiderivative? Wait a second. That's a power rule. Let's apply power rule backwards. So the integral of x to the negative 1/3 dx. According to the power rule, we need to add 1 to our power. Plus 1 would be plus 3 over 3. And then we divide by that new power. So we got to work out our power. What is that going to be? So negative 1/3 and positive 3/3 would be x to the 2/3. And we divide by that new power. We're dividing by a fraction, we flip it over, and forget, plus c, plus c, plus c. This is the antiderivative of the original function in problem 2 here. It's all squished together. I'm sorry. See if I can look it up for notes purposes. Here we go. If you want to check your work, you should always check your work when you do antiderivative. Derivative. So if we did power down, we multiply and cancel. 1 power less would be negative 1/3, which is exactly what we started with. So check your work. Oh boy, cosine of 3x. This is tough. What function, when I take the derivative, gives me cosine? Well, in other words, what is capital G? Using capital G is the best because my original function was little g. So take capital if you want to do the antiderivative notation, or you can use the integral notation. So the antiderivative of cosine of 3x is well, hopefully you remember, sine and cosine are the derivatives of each other. So you gotta watch out for the negative. So let's write sine, and then we're going to determine if we need to put a negative sign or not. And the inside, remember, has to stay the same. Uh-oh. Wait a second. All right, we're going to check our work. We're going to take the derivative. The derivative of sine is cosine. No negative needed. We're good. We got exactly what we wanted. We have this 3x. So let's review. What is the derivative of sine of 3x? So I'm checking my work. I'm checking to make sure I get my original function when I take the derivative. The derivative of sine is cosine. The inside stays the same, but then what do we need? We're going to do the chain rule. The derivative of the inside has to multiply here. Our original function didn't have that. So we have to make up for it. We have to divide to get rid of it. We're going to have another technique later called U substitution, which will also be able to do this for you. But some of them are straightforward like this one, where you should be able to adjust on the fly. You shouldn't have to do this stuff. So what I'm going to do is I'm going to divide my antiderivative by 3. If we divide our antiderivative by 3, watch what happens. So d dx, our antiderivative we're saying is sine of 3x over 3. Well, look at the 3 out front there, over 3. The derivative of this, the 1/3 chills out. We multiply by the derivative of the rest of it. The derivative of sine is cosine. Inside stays the same, times the derivative of the inside. The 3's cancel, and we end up with our original function. So I just checked my work. Yes, this is in fact one of the antiderivatives. To get the entire family, we simply add pluses. This would be the antiderivative of the original function. Alright? Give me a pause and go back and review. Go back and look it over and make sure it makes sense to you. And I have a blank page. There it is, number 4. Alright. So number 4. Oh boy. E. E was special when we did derivative. E stayed. Well, that means the antiderivative has to follow a similar pattern. So let's just big guess. Let's guess that the antiderivative is going to be the same as the derivative. And then we're going to check our work. So if we take the derivative, then d dx of e to the negative 4x, let's see if we get the original function back. Well, the derivative of e is e. The inside does stay the same, but the inside is interesting. It's got something going on. So we need to do the chain rule. Chain rule says we got to multiply by the derivative of this. What's the derivative of negative 4x? 4? Well, that's not the original function. So let's fix our antiderivative. We're going to divide by what's extra. So we're going to divide by the negative 4. You can actually put it underneath everything, or you can put 1 over the negative 4. Negative can go top and bottom. Just reciprocal. That is the antiderivative, one of them. How do I get the whole family? You put plus c. And that's it. We're done. So basically, we're taking a guess, and then we're working back by checking our work and saying, okay, do I need to adjust for this? Do I need to divide by some number that would have been multiplied the derivative? That's what you're doing. All right. Now this one I probably need to remind you. This is the case where you have a to the x. So a number to the power of x. Let's review the derivative formula. You guys might not remember it. The derivative of a to the x is similar to e to the x. a to the x stays the same. But difference is you have to multiply by ln of the a. If this had been a u up here, this would be the u, and then you would need the derivative of u at the end. Yes. If it had been u. In this case, it's just x. So that's the derivative. Now, how does the antiderivative work? So capital K of x, we're going to integrate by the antiderivative of 4 to the x dx. Well, let's start by the x. It looks like it could just be 4 to the x. Something not quite right. Let's check. If I take the derivative of 4 to the x, will I get back my original? No, I'm also going to have this ln of 4 going on here. So for the rule for integrating a to the x dx is that yes, a to the x stays the same, but you have to divide by ln of the a. So in our problem, we actually have to divide by ln of the base. Check your work. Take the derivative. You're going to end up with an ln of 4. We take the derivative, divide by ln of 4, because we have one here. They're going to cancel out, and you'll get back the original. Plus c. Don't forget that plus c. Alright. Like I said, we're doing lots of these. So if you're not getting it the first try, finish out the video, and go back over them and try and review. If you're still not making sense here, then let me know, and I'll try and get you another perspective on how to do this. Secant, tangent. Oh no, we need product rule. No, it is antiderivative. What function, when you take the derivative, gives you secant tangent? Remember? It's either secant or tangent. The derivative of secant is secant tangent. So if I had started with secant and took the derivative, I get secant tangent. Whatever's inside stays inside. But if I take the derivative, I also have to multiply by 2. So in the antiderivative, I have to divide and make up for that. Look, let's check our work here. If we take the derivative of this, of our guess, we would end up with 1/2 tilled out times secant of 2x, tangent of 2x, because the derivative of secant is secant tangent. Then the inside, we need the derivative of the inside, which is 2. The 1/2 and the 2 cancel, and this is the original problem. So yes, this is the correct antiderivative, but don't forget to put your plus c so that you have the entire family of antiderivatives. Alright, so we did that one. Now let's do secant squared. What function, when you take the derivative, gives you secant squared? Well, it wasn't secant, we just did that. Secant is secant tangent, so it's got to be something else. Remember, it's tangent. The derivative of tangent is secant squared. Inside's still going to be the same thing. That's not going to change. But remember chain rule. You have 4x inside. So if I took the derivative, I would end up with a 4. My original problem didn't have a 4 in front. So we have to divide by the derivative of the inside. So that when we take the derivative and get back to the original, that 4 won't be there. Don't forget plus c and 2. Going way too fast on these, I feel like. I'm sorry. It's hard to slow down when y'all aren't here to ask questions and stop me and all that good stuff. But please email me questions that y'all have. And we'll make another video. Alright, here's another one. Oh, multiple terms. When we do derivatives and we have multiple terms, we deal with each term individually. Same thing for antiderivatives. We're going to deal with each one of these individually. So what is the antiderivative of this function? We're going to integrate 1 over x minus 2x to the negative 5 plus p dx dx. The whole thing we're going to take the antiderivative, but we're going to do it as if each one was its own separate problem. So if you want to rewrite this, integral of the first term dx, integral of the second term dx, integral, you can. But a lot of notation that I would never see you actually do. So this is fun. So first term, what function is the antiderivative of 1 over x? Meaning, what do you take the derivative of to get 1 over x? Remember, ln of x. If you take the derivative of that, that is 1 over x. So that means if we integrate 1 over x, the antiderivative is going to be the ln of x. You know. This is one of those tricky ones where people tend to want to do power rule. You tend to want to write this as x to the negative 1 and do power rule backwards. The problem is when you add 1 to the power, you get a 0, and then you divide by the 0. That will work. That's when you realize, oh shoot, this isn't power rule, it's ln. One of those very special cases. 1 over x is special. So the first one here we've worked out is ln of x. The second one, all right, second one is power rule. So the 2 is going to chill out while we do the antiderivative of the rest. Power rule says backwards, we need to add 1 to our power. So negative 5 plus 1 will be negative 4. Then power rule backwards says we need to divide by our new power. There you go, that's your antiderivative. Simplify and then check it. Make sure you get the original problem back. What's the antiderivative of e to the x? Well, the derivative of e to the x is e to the x, so the antiderivative of e to the x is e to the x as well. If there had been something interesting up here besides x, we would need to take the derivative, do the chain rule backwards basically, divide by that constant that we get from the derivative. But in this case, there isn't anything interesting up there, so we just need to finish this off by putting our plus e. We simplify the middle term, so negative 2 divided by negative 4 is positive, and it'll be 1 over 2. If you want to put your x downstairs, you can, or you can leave it upstairs. I don't care either way. And there you go. This is the antiderivative. So whether you have 1 term or 3 terms, you just